find the exact value of sine 105 using a half angle formula. Now, let's define the problem here. If I am looking at 105 degrees, remember the initial side of our angle is the positive x-axis. So if this is 0 degrees, isn't it gauche to use degrees? We love the radians. 105 degrees is going to be around here, right? And so if this is 105, that's 180. That forces our reference angle P to be 75. And exact implies don't use a calculator. Do you see that we've got 30, 60, 90 special triangles, and we've got 45, 45, 90 special triangles? I don't know. I don't have a 75, 15, 90 triangle. So I'm kind of stuck. In the past, we said we could write this as sine of, well, I could do, let's see, how could I split this up into 60 degrees plus 45? I know those reference angles, right? Or I could say this is sine of 135, reference angle of 45, minus 30 degrees, reference angle of 30. So that's what we did in the past. We said either use a sum formula or a difference formula. Now, look at the power we have with half angle formula. It gives us yet another option. So how do we approach this using half angle formulas? Well, this here is 105 degrees over 1. I can't change the angle, but I can change the numerator and the denominator, keeping the angle the same. This is the same as sine of, well, I want to use a half angle formula, right? So I want a 2 in the denominator to use my half angle formula. So 1 times 2 is 2. If I multiply the denominator by 2, I have to multiply the numerator by 2 as well to give me 210 degrees. Now, when I draw 210 degrees, that's here. If this is 180 degrees and this is 210, that forces this reference angle to be 30 degrees. If I make this a unit circle, this is -1/2 and -√3 over 2. All right, so I know that I am talking about this formula. Sine of theta over 2 is equal to 1 minus cosine of the numerator theta over 2, and I'll put a square root there. Now, at the very end, I'll decide plus or minus. So playing the role of theta now is 210 degrees. Look at the formula. Whatever's in the numerator goes there. So this will be plus or minus the square root of 1 minus cosine of 210 degrees over 2, which means sine of 210 over 2 is equal to plus or minus the square root of 1 minus over 2. Now, what is cosine of 210? I know cosine of an angle is a ratio. I'll put my Azavici eyeballs looking through this reference angle. The cosine is adjacent over hypotenuse. So this is -√3 over 2. Now I'm going to have to clean that up. So this is equal to plus or minus the square root of 1. Now, minus a minus is going to be plus √3 over 2. Now look at the little math games I'm going to play. I'm going to write 1 as 2 over 2, and I'm going to divide this all by 2 over 1. So when I do that, you hopefully can see that this here is going to become plus or minus the square root of 2 plus √3 is 2 plus √3 over 2. That's my numerator. Numerator plus numerator over the same denominator. So that fraction is my numerator, and this is over 2, and I'll make that a fraction. So I've got a complex fraction of the form a over b over c over d, which calls for us to, look what I'm doing over here, a over b over c over d. We're going to keep this change and then flip. So this is equal to plus or minus the square root of 2 plus √3 over 2 times, now I'm going to flip this, 1 over 2, to give us plus or minus the square root of 2 plus √3 over 4. Now, what you have to know from algebra is if I have the root of a over b, I can write that as the root of a over the root of b. So I'm going to write this as plus or minus the square root of 2 plus root 3 over the square root of 4. And hopefully you know that the square root of 4, oh, so ugly here. The square root of 4 is 2. So there's my answer. Almost. You see, I didn't have the triumphant music. I have to decide, is this a plus or a minus? And I'm going to remind you of the very important statement. Here it is. The plus or minus of sine of theta over 2 or cosine theta over 2 depends on which quadrant theta over 2 lies in. So I'm going to encourage you to circle which is your theta over 2 angle. Here it is. There it is. 210 over 2 is theta over 2. Well, that simplifies to 105 degrees. That is theta over 2. So theta over 2 is 105 degrees. I'm not sure. So we have identified theta over 2 as 105 degrees. Well, it's as simple as this. If you draw 105 degrees, here is 105. And of course, A, S, T, C. We were asked to find the sine. This is a second quadrant angle. What's the sign of the sine in second quadrant? It's positive. It's that easy. Now you might say to me, well, do I take look at the original angle here. Do I take the original angle? I always say, make it simple. If the rule is to look to theta over 2, then circle the angle with 2 in the denominator and then simplify it. Circle the one with 2 in the denominator, figure out where that is, and then use ASTC. It's as simple as that. For the life of me, I'm not sure why this gives students so many fits. Even my best students wind up just guessing at the plus or minus. But it's easy. Find theta over 2, simplify it, then do ASTC on that angle. Let's say you were given sine of 7 pi over 12 and told to use the half angle formulas. One option would be to convert this into degrees. This is sine of 7 pi over 12 times, remember, if you have radians, you want radians in the bottom and degrees in the numerator, which when you do your math gives us sine of 105 degrees. And this is the problem we just solved, because we could say this is sine of 105 over 1, which becomes 210 over 2. And we do all the work we just did. However, if you don't want to go to degrees, you could call this sine of, now we want the denominator to be 2 to use our half angle formula. So to go 12 to 2, we have to multiply by 1 over 6. If I multiply the denominator by 1 over 6, I've got to multiply the numerator by 1 over 6 to give me 7 pi over 6 over 2. Now, this is sine of theta over 2. I've forced 7 pi over 12 into something over 2 so that I could use my half angle formula. Now, in this case, this is plus or minus the square root of 1 minus cosine of theta over 2. Notice the theta in this case is 7 pi over 6, right? Our theta is 7 pi over 6. Some students have trouble seeing that the formula calls for this numerator to become the argument of the cosine. So 2 options there. If you're given radians, convert to degrees, and then you can perhaps use that that idea of fraction over 1 is what over 2. Or if you want, just use this fraction. You're multiplying by 1/6 in the top and the bottom. And then, of course, if our reference angle has if our angle theta has a denominator of 6, then we know that our reference angle will be pi over 6 or 30 degrees.